Stuff. We've actually talked about this a little bit. If I just ask you to draw an angle, the reference angle is the acute angle formed by theta and the terminal side. Okay, so it's the stuff in between the x-axis and the terminal side. So if I draw a picture of this, 130 degrees, it'd be like, let's say right there. So that's 130 degrees, right? But I typically don't work with 130 degrees. I will work with that space that's in between the terminal side. So remember, we've been drawing our triangles, right? And I keep saying theta is between the terminal side and the x-axis. So what is theta?
50.
So that's your reference angle. Right there. Okay, 210.
30.
Put the terminal side in approximately the right location, so that's somewhere down there, right? 210. If you're thinking about like your unit circle. Well, what's my space between the terminal side and the x-axis? Right. So you've gone from 0 all the way to 180, and then what are you doing? 30 more. So 180 to 210 is what I'm asking. How far is that, right? So that's 30 degrees. So if your angle's in the second quadrant, your theta prime, let's call it, your reference angle, is 180 minus theta. And over here, your reference angle was 210 minus 30. Those actual numbers. I want 180. Sorry. It's your theta minus 180. So they're using theta. We would use like theta prime to represent your reference angle and theta to represent your given angle. So that's why yesterday when we talked about the unit circle, I was talking and I would do the air quotes, quote unquote, the 30-degree angle in the first, second, third, fourth quadrant. So 30 degrees, 150, 210, and 330 are all 30-degree angles. Because it's really all the reference angles are 30 degrees. Okay, 315. Keep doing the same thing. The terminal side somewhere down into the fourth quadrant. So I go around 315 degrees. But really, what am I going to be working with? A 45. So when you think about this one, I guess to stay in the same theme, theta prime, here you would do 360 minus the theta that I give you. So the question is, should you draw your picture? I think it's easier to answer the question based on a picture rather than trying to memorize those purple things. But that's the math that we're doing. The purple is the math that we're doing. I think if you understand your angles well enough, you'll be fine. The weird thing a little bit is when you do the problem in radians. Now, remember, on the exam, if you want to take this radian and convert it into a degree, it might be easier for you, but let's do the radians. Where is 4 pi over 3? So 4 pi over 3 is somewhere down in the third quadrant. So that's 4 pi over 3. Then that means my reference angle would be sitting right there. Well, remember, this means I'm more than 180. I've gone beyond the 180. So how much more? So my theta in this case would be the given angle minus 180. What's 4 pi over 3 minus 180? Or 4 pi over 3 minus pi?
1 pi.
Yeah,
Pi over 3. Now in a problem like that, a lot of you, once you get into working with the unit circle, might just say in your head, wow, 4 pi over 3 is the same as 240. And I know that 240 is 60 degrees beyond 180. And I know that 60 degrees is pi over 3. I mean, so if you convert back into degrees, I really don't care. It's easier for you. 4 pi over 5, though, is not anywhere on the unit circle. So where is 4 pi over 5? It is quadrant 2 because 4/5 would be more than a half, but not 1, right? More than a half, but not 1. So we're right here. So I've opened it up 4 pi over 5. So to find my reference angle, I will do 180 or pi in this case, minus 4/5 pi. So you can go to your calculator and do the work, or it's pi over 5, right? So you could always take it on your calculator, do 1 minus 4/5, and then hit math, enter, enter, put pi back in. Last one, where's 11 pi over 6? We're going all the way around. 11 pi over 6. Oof. A lot of you might be thinking in your head 11 pi over 6 is the same as 330, right? But I haven't quite reached 360, so when I calculate my reference angle, I can do 360 minus 11 pi over 6, which would be, again, pi over 6 for the reference angle. Or you could have written down 30 degrees had you converted it into degrees. So the question is, why did we not do an angle in the first quadrant? So if I draw an angle that's 45 degrees, what's the reference angle? 45 degrees. So there is no reference angle in the first quadrant is why we did it, right? Because that is, not only is it the angle I give you, it's also the space between the terminal side and the x-axis. So they're one and the same then. I'm not really sure of all of a sudden why this is in here either. I don't know, but it goes ASTC. So put that in there. You've done some of this work already? So get a calculator out. No.
ASTC.
Oh, we're good. Get your unit circles out. Maybe flip back to yesterday's lecture. Where's 4 pi over 3? Where's 4 pi over 3 on the unit circle? Somewhere down in the third quadrant, right?
Yep.
What's the ordered pair at 4 pi over 3 or 240 degrees? What's the ordered pair? You're over 3, right? The denominator is 3, so that tells me you're dealing with a 60. So when I do the hand trick, I get 1/2 root 3 over 2. But what quadrant am I in? The third. So both of those answers are negative. Which one's your cosine? The negative 1/2 or the negative root 3 over 2? What? It's the negative 1/2. So when they talk about exact values, I know you guys can type this into your calculator and get decimals, but when you see in the definition or in the question they're asking for exact values, that means go to your unit circle and give me the fractions or the unapproximated number. Do the next two on your own, let's see how you do.
It was pretty crazy.
So where did negative 210 put you?
I already got B and C right.
You start at 0, you go down to the bottom of the unit circle, back up, and a little bit more into that second quadrant. So it'd be about right here.
Guys, I would kill you if you didn't like that.
210, 210. Start at 0. Start at 0. Go negative 90, that puts you at the bottom. Go negative 180, that puts you on the left-hand side of your unit circle. And then go an additional 30. So what I'm writing up there is it's going to land and be coterminal to 150 degrees, right?
Sure.
Quote unquote, it's your 30-degree angle in that second quadrant. So for me, I can just flip my hand trick. I got root 3 over 2. 1/2. And what was that?
Negative.
Why?
Because it's in the X line.
Because in the second quadrant, your x is negative. Yes. So when you go to do the tangent, your sine, which is this guy, and cosine, which is this one. So you put your sine on top. Instead of dividing by cosine, I'm going to go right into multiplying by the reciprocal. The 2's cross off. You have 1 over root 3, and this is a negative answer. And then what do? Then you rationalize it. So I end up with negative root 3 over.
Oh, when you multiply,
Root three.
flip the root 3.
I went right into multiplying by the reciprocal.
Oh, yeah.
So instead of dividing by this, I went right into multiplying by the reciprocal. Now, folks, you could start to memorize some things about tangent, and sometimes it speeds things up. When you work with tangent, what's the tangent if you're working with one of the 45s? What's tangent of the 45-degree angles? 1 or negative 1, right? Because it's root 2 over 2 divided by root 2 over 2, and it depends on if you're working with 1 or 2 negatives. So it's either 1 or negative 1. When you work with the 30s and the 60s, you either get root 3 or you get root 3 over 3.
Yep.
Got it? So you could do stuff on your calculator and get those decimals. Root 3 over 3 is smaller than root 3, and root 3 is about 1.7. Root 3 over 3 is what? About 0.57 something, I believe. Is that what it is? Can somebody do root 3 over 3? No, it's about 0.8. Is it 0.8? Somebody do it. What's square root of 3 divided by 3? What? 0.57, the first number I said you. Okay, so you can memorize that. What about secant of 11 power 4? Where did 11 power 4 put you? If it's more than 2 pi, or if it's more than 360?
Reciprocal.
Like 7 pi over 4, that's okay. 8 pi.
So this is 2 and 3/4 pi, right?
Yes.
4 goes into 11 twice. That would burn up 8 of them, so there's a remainder of 3 left over. So that's, I'm switching to the mixed number. So the 2 pi tells me that it did go around once. So really, all we need to concentrate on is where's 3/4 pi?
Second quadrant.
Second quadrant, right about there, right? So again, I'm just going to do this, quote unquote, it's a 45-degree angle, right?
Yes.
3/4 pi. So there, your order pair is root 2 over 2, root 2 over 2. Because I'm in the second quadrant, the first one has to be negative. What's secant go with? Cosine, the first one. So we're going to do the reciprocal. We're going to do the reciprocal of this one. So we go 2 over root 2. It's a negative number. You rationalize, and you get negative 2 root 2 over 2. Bunch of 2's in there. Get rid of those guys, and you're down to negative. That would be your secant. So this is how the unit circle works, and I don't ask you to fill in tables. It'd be more like that problem. So you have to understand, how do I get to 11 power 4? What does it mean? What's my sine? What's my cosine? What's my reciprocal?